Why is it fucking working all of a sudden? Dude, I don't get this shit. Bullshit. Also, look at these temperatures, bro. Man, that's screwed up. Alright. Anyways, everything I had just explained was lost to time because it never got streamed, and I thought I was streaming this entire time. But we moved away from the shit that we were doing before, where we essentially we weren't doing a tree. I thought I was doing a tree, but I wasn't, and I don't really know what I was doing. I think I have a better idea of what to do now. So the idea is like, yeah, we just have a tree, and like, really simple. It's like, you know, um just like take a look at our syntax real quick. So we have some, everything is like a block essentially. Maybe, I don't know if comments are blocks. No, comments are just comments. They're stateless. We don't have to do any inner parsing. We just, like, we know everything there is to know with a comment, so we don't worry about comments that much. Then it comes to like these blocks, right? Like pretty much this is a block, I think. And blocks are like the most general case for what could be represented by the language, right? A block in the most general sense could be anything, pretty much. So, like, it could be this assignment right here. Let's just take a look at what it could be in our language, like what it could be. So, here are like four cases. So, I don't know, maybe these aren't really four cases, to be honest. So, like, it could be an assignment. Yeah, this is also an assignment. It could be an access operator. It could be a return value, because this would go at the end of an expression. Like, this is just f of x 4, right? Where f of x, or f of, like, that's it. That's all that is. Those are the same thing. These mean the same thing. So, and then we have like a function call. But in the general sense, these are all just blocks. Like, these are all things you would just have a semicolon at the end of them, except for this one, I guess. You need to put something like this. But like, yeah, in the general sense, these are all blocks. These all, they're all blocks, but the way we parse them isn't stateless, in the sense that you can't know this is a block just by parsing the name. Like, this is a name, right? We know for sure this is a name. Whereas with a comment, we can parse the entire comment statelessly without having to worry about the future, what the future holds. We know immediately. So maybe not stateless. Stateless isn't a good word. I think it's an immediate like, we know it immediately. That's it. So, right, kind of the question is, how do we work with these non-immediate syntactical things? Right, because in the most general sense, everything depends on the future to know what it is. So, well, how can we work with this? Well, if this is a block, then what does that block, what is it composed of? Right? This could be like a block is a list of these different syntactical features, and we can just lay them out like this. Right? Except it's more treed. It's actually treed because this is like an assignment operation. An assignment takes a value and it takes a name, an address, and a value. And this is the address, right? So like this is like an address. And then this is value. And like this could be seen as like a sign. Right. Who knows, this could be over defining things. And an address is like an address, I don't know. What is an address? Yeah, like I really just don't know. I'm still playing around with it. It seems kind of ambiguous, but I think the main goal is to just destructure these things into very fundamental like operations. So, and who knows, maybe like that we'll just find clarity along the way, but I don't really know what I'm working with. So, let's see, are we still live? But yeah, let's see what we can do with it. Yeah. Is the audio quality good? Yeah. So, no need for me to draw a diagram or whatever. How are temperatures doing? Okay. So yeah, we're essentially trying to move away from whatever it was we were doing before to everything's a node. Nodes have children, they have a parent, and this should kind of make it semantically easier to just navigate and deal with this memory. Because I think what we need now is like a versatile approach. Just because, like generally speaking, that's what you're supposed to do when you don't know what you're dealing with. Is you have the most unconstrained approach. And like yeah, nodes are pretty unconstrained. Like they're pretty general and they're easy to fuck with, and yeah, and then we can start simplifying down once we understand what it is we're working with. So we have some initial state, and like a block state, I guess. Are we gonna call this block? Or are we gonna call this yeah, like it's a block, I guess. Yeah, I don't know. We're gonna IDK what this is, and we're looking for a few things. Like we're looking for like if statements for, while, and we know that these things are always followed by an expression, and then an expression is like its own thing, right? An expression could be object. And are we supposed to be pushing? Like that's another thing. When do we need to push versus pop? So I think we push whenever we encounter a state which depends on the future. As in, we don't know what that thing, we don't know what is encapsulated in that thing until we pop. Right? Like that makes, I mean, that makes perfect sense. Right? We, push and pop. Push, build up context, then pop that context and do something with it. So, like, of course, we don't have to do any pushes for like strings because they're stateless. They're immediate, I think is the word to use. So we have this access, just like access operator. Like, do we need to hold state for access? What is the problem we're trying to solve? Well, if we're accessing something, we're at the end of the day we're looking for, like, this is memory. This idea is memory. I guess this is like name or like memory. I don't know which one what we should call this. Maybe we should just call it memory, or like location. We should call it location actually. So let's change it from name to location, because that's really what it is. It's more or less a memory location. And right, so we have locations. Well, if we're a location, and we put parentheses around it, then this is certainly a function call. So the assumption here is that the inference that could be made is that if we're using these, then we know that location refers to a function. It should. So it's kind of interesting, right? Because it's like we don't really know what this means until we read the whole entire problem, right? So, and yeah, let's say insert child. So I think we're just working with comments right here. So yeah. Another thing about comments is I want to be able to capture what the actual comment is. Like, I want to be able to capture the contents. So we can focus on that later, I guess. The idea is, yeah, we can just parse that shit out. Insert child. Let's print the children. Print the type. Look at that, and it's just building up this tree. I don't know what this is. Yeah. Interesting. And maybe we should have like a depth thing. No depth. Okay, let's just say depth equals. Also, let's just do this. Depth equals parent back there. It's 1. Or 0. Or no depth. Or 1 because it's Lua. Lol. Oh yeah, 1. No, 0. Let's go ahead and print stack. parent get depth plus 1, which doesn't exist, parent, or I don't know, like just say parent or no parent or get depth. Yeah. This should be plus 1. Are you getting these? Lol. Yeah. So here that is not a thing. Oh, it is a thing. Oh! No, that's not right. No. Yeah, because this is like we're writing to we lose information. Right? What we should be doing is we can keep track of this globally. And then we could say here parsed is more or less going to be current. Right? Is going to be currently parsed. Let's just call it phrase. I like that. I don't know why. Now I can insert child. And then after I want to print the tree at some point, but for now we're just going to say print. We're just going to get the children. So we're going to insert a child, print the children here. Look at that. We have all these comment looking videos. see what we got here. Um, yeah, why are we doing that? Also, children should just be nodes. Like, this is wrong. This is super wrong. That's why. That's why it's fucked up. So, we shouldn't be inserting value. Unless value is a node, but it should just really be nodes. Insert. Oh, we're just going to call this insert. And then insert. Right, this has to be a fucking comment node. And we need some kind of type. Sorry, we need some kind of value thing. We can just do this. This is fine. I'll create the node. Comment. This is like terribly overcomplicated right now, but it works. And then now, and we can just say this. Like, we can just print. Right, we can just print the child. We can just say this, like, node.print. We can make a print function where all we do is iterate through the children, and we simply print. How do we repeat strings? That's not true. There's no way that's true. Whoops. Oh my gosh. Oh wow, I didn't even know that. I didn't know that existed. I honestly didn't. Embarrassing. Okay. So, right. We don't have to do that. We just inline it. Child, children, I dot. That's fine. We just say that for this one. Yeah, I mean that this works for now. I gotta fucking shit. Fuck this guy. Okay. Ugh. What? Whoops. Oh, these are children, and they would have a higher depth than me. Yeah. So I guess that's it. Insert. Yeah. And another thing is, I would like to be able to print this entire tree. So yeah, we just need to like recursively print. So print should really call the prints within that. Yeah. And then so okay, we just print every child. Yeah. And then let's break out of this tree, whatever we call this thing. Let's just do this. And then down here, we just print it. And then what should do something. How many children do you have? What is here? Here's a tree, right? Here is the tree, yeah. So why doesn't this work, huh? Oh, because are we calling pop? Yeah, that's the issue, I think. So that's what we're not gonna do today. What? What? Are we not fucking doing shit? Insert. What does insert do again? Yeah, no, it just inserts a child. And then I think we're pushing. This could have something to do with it. Yeah, probably just push. Because this creates a new node. Yeah. And it should not be changing this, I think. Yeah, we're just gonna not do that. So this we do node. Yeah. Oh, you know why? Because this probably should be assigned to the tree. Is this not getting called? I'm fucking stupid. We can't have a parent unless we're inside the child of that. So okay, if we insert a node, then node's parent will be, sorry, then the child's parent will be us. And then we should never be assigning parent. Yeah, that should never be the case, I think. And then essentially we don't need this here. Yeah. And this is more constrained. We're not going to do this, honestly. We're not going to do these get things. These are just honestly constraining. We're just gonna do this. I'm just gonna say, yeah, like node step. Children. Oh, I don't know what I'm doing right now. Yeah, so depth should be node.depth, and we get rid of the node nodes. Get node. Otherwise we give this fake node parent or yeah, this could be get down into just really nice. So the depth should be the parent's depth plus 1. The parent and node parent depth is 1 or 2. Right. And is it supposed to have a depth? Yeah. Children. And now we don't assign parents anymore. Instead, what we have to do is assert it. Now, like now it works. Okay. Another thing is, should we be explicit about the parent or like what if we're just gonna say this current dot insert node. So Yeah. I don't actually know if this is effective or not. But yeah. So make an expression node. What does is do now? Is this type? Type. Is here that type even global anymore? It's not. So this. And then yeah. So we print the thing that we just parsed. We make a node. We set the value to the thing we just parsed. And we insert it into our current deal. And let's print it here. Oh, this is problematic, isn't it? Okay. Yeah, we want to make sure that we're not this maybe. Yeah, we don't want to do this. So then I can do that. Just got to set. And then yeah. I guess this should happen by default. This insertion. Yeah. So yeah, this should just happen by default, I think. Yeah, so who knows? So we don't need this anymore then. Yeah. And then obviously we're not gonna set state to that, but yeah. So let's print. Okay, so now let's just say this. Print, create a print. Yeah, we should probably see. I want it so that this captures the comment. So it should be something like no new lines, no space. No. Um, yeah, I don't know. I get it. So okay, I get it. I think I get it. So I think actually I think I get it now. Goal is to get the value, but the value has to compile everything. The value it could be a result of compiling all the children, and then so like the so like this. Let me just say this, and then like no, like that's it. And print is just going to be getting the value of everything between, like everything below. Yeah, something like that. But yeah, like if so, we don't even need print. We just say get the value, and then right in this case, we already have value. We should probably not do this right here. Instead, we should say current arrays. We were doing this before, weren't we? But I think, yeah, this is. I think this is the right way to do it. Maybe each shouldn't be some global thing. Maybe it should be a node, like on the node level. Anyways, we're just gonna try it. So node. It's not right though. It's not right that way. Yeah, no, it kind of has to be this way, I guess. That's fine. This should just be called parse maybe, or I don't know, get value. And then the idea is if we don't have value, okay. Make a node. That node gets inserted into here. These are not stateless. This is stateless. This might be stupid actually. Grams, okay. Gotcha. What happens if we set here? Okay, location. Grams. We get to an expression which takes us to an object, which makes sense because we're here. And then we probably finish. Yeah. And then we have, then if we pop, then where does that take us? Right? Here that takes us to an expression, which is where we were before. Okay, and if we pop 2 times, then that takes us back to location. This shouldn't be pushed and popped. Like, this doesn't describe a recursive thing. Right? This is... Like, this doesn't represent a tree, does it? This block right here. This is a location assigned to a object. Assigned to a value, which is an object. I think maybe we shouldn't have expression, maybe. I don't know. We'll figure it out. Let's actually just add more shit. So we pop. That takes us to the previous state, which is expression. And at this point, where are we going to be? Okay. No. Where does that take us? That takes us to location. Yeah. So for a location, we're at like this dead. Okay, you know what we do? We just pop. That's it. We pop in the unknown case. I think that's all we do. We just pop until we're fucking all the way back. Yeah, so not good. That means that we don't have a continuation. So, gotcha. Okay, this makes a lot of sense now. So, this pops, essentially, just pops us as far back as we need to go. Like, okay, so I think the idea is we're in these states. We eat what we recognize, and if we can't eat it, then that means it's just not. It's not like a case, maybe, and we just pop out until we're back to where we need to be. I don't know. I don't know what this is. What the result of this is going to be. This might create a lot of bad problems. But I think it'll just start to fix itself as soon as the more we fill it out, the more information we provide. So I think at some point we're going to be in the IDK what this is state. And if we're in IDK what this is, and we start out with a curly brackets like this, then what does that mean? Well, I'm pretty sure that means either a return value or a scope, like a block. So I think it just means block. We're just gonna make a block. So let's eat. Right, if we eat this, then yeah. And look at we've continued. We got location, expression, object. Where did we get that? Look at that. So we have operator map. So like literally we can just print these out. And yeah, look at like we have the operator map followed by an expression. That's not right. That should be inside. That should be assignment, not expression. Also, assignment is it stateless? I don't know. Assign. Yeah, this should be like assign, maybe. And that's just gonna terminate there. Who knows? Maybe it is expression. I don't know. We'll figure it out. Like we're just gonna figure it out. Locations, operator map, object. We get an object. Yeah. We get an object. Then we're gonna get these indices. So the thing is, like, it could be an index or a value. We don't know what it is. We don't know what it is until we figure out what's after it. So we know that it has to be either a value or an index. So like that's it. We just call it index or value. Right? So yeah. It's an index or a value. So we're stuck at object. And if if we eat. Actually, it has to be a literal, doesn't it? Does it? No, it does. No, it doesn't. It just has to be a. It's. I think we'll figure it out. If it's a string, a literal. Yeah. It could be a literal. It's a literal. Pushing it is a stupid way. It's a character. It's a string. It's what did we call this again? A name. It's a name. Oh, it's a number. How to match a number. I just want a number. Yeah. A number. Right. Then it's a number. Nonetheless, it's just this is so fucking okay. This is pretty disgusting so far. Object. So we're in the object state. But not being. Oh, you know why? Because limbo. If limbo. Another thing is like these eat. We should keep track of. Here's another thing we should do. Keep track of calls. Per state. So that we can optimize, so we can sort edge pieces by occurrences we set ascending. This will make things faster. We'll do that later. This is like really gross so far. What do we call this? Empty. Look at that. And we should always do that, maybe. Yeah. Eat the empty. technically this is just a char literal local char literal, and that's stateless also, which makes things nice for us. It's just going to be actually pretty much we can just match anything. So yeah, whatever. That's a char literal, I guess. And then eat a char literal. We could eat a what else? Eat, string literal. String literal is gonna be, that. Let's just see if it works if we do a string literal. Yeah. Um, yeah. What else can we get? Like, this is stateless. This is stateless. Name is also stateless. We will. Oh yeah, we already got that incorporated. Number is stateless. It's all stateless. And then we need to eat and assign because there's going to be a one. And that means it's going to be followed by an expression. So we have to make a new node for expression. Set that to the current state. Then it's going to assign to a string literal and make node. I kind of just want to print the type, to be honest with you. Set. And then honestly, we just don't even need to do that. We can print the phrase here. Yeah. Look at that. It's coming together, guys. It's starting to come together. Like it's slowly but surely becoming something more and more clear as we work on it. And yeah, so like that's just the great thing about working on things. You just clarity creates more clarity. Great. So also this isn't really right to call this expression, but we'll figure that out. String literal. Yeah, we're gonna figure this out. So Another thing I kind of realized is like there is some kind of significance to if we can eat it statelessly, then like this should just get added to the parse tree, I think, just automatically for these stateless things. So, hmm, yeah. So where we eat it and we don't pop, we just eat it and we don't pop. Those describe, yeah, if we eat it and we don't pop, then that just means that we essentially we're just adding it to the children. Like we should be adding that node to the children. So like, I mean, in these cases, we just say like, yeah, we just create a new node. It's going to be this thing above it, which we'll have to give names to eventually. Didn't really work out as I wanted it to. But... And essentially, we are going to. What are you doing with this shit? We're making the node and we're just going to insert it into here. And I think we're already doing this. Yeah, we're already doing this. So we don't need this. We make the node. And in general, not in general, we don't know the generals yet. So we just say this, okay, here's a node. And we're going to assign it some value. Being the phrase that we just got. Yeah, that's it. So, and we'll make phrases better because right now phrases are kind of, what's the word? Right now phrases don't extract the thing that we want. They kind of just select the entire parse tree. Like I don't need to know that this is a string by encoding the strings. Like there's a more efficient way. I could say like add as a string. Like we could say like type is a string and value equals add. Like we don't have to include these things explicitly, you know what I'm saying? So the next kind of goal is to just store the type and value, right? And that's not really what we're doing now. Like this should be more or less this. This should be more or less this. And yeah, we have to change a few things before we can do that. But we'll get to that. We'll get to that. So, Charlie, I'll turn the role name. I'm doing. Another thing is, do we need? Yeah, no, yeah, we need that. We need that. Okay. Yeah. Not good, not good, not good, not good. So that probably happened because, yeah. String literal. Um, why is it, how far is it getting until it's getting all the way down? Yeah, because it's choosing the farthest one. See, this is like the thing about regex that I don't understand. Like, why is it a maximization problem? Why are we going as far as we can? Shouldn't it be like the first, shouldn't it be like a minimization problem? Is the way I see it, but I guess not. Um, how can I, how can I get a regular expression to match the closest case instead of farthest one? I don't really know how to explain this one. Oh, is that what that is? Okay, I just realized we need to match not quotes as well. That's it. Yeah, that's it. Right, so the idea is, yeah, that's it. I mean, we start with a quote, we end at a quote. I think the way we were saying it before is we start at a quote, we get everything until we get a quote. And the idea of everything is like maximization in itself. So actually this I think it does make sense, right? Whereas this is more about we start at a quote, we end at a quote, right? Um, Same thing here. It's like we start at a equal sign, we end at an equal sign. We may end at an equal sign. We certainly will end at a quote here. Yeah, that's it. That's it. That's it. And here, it's like we start at a comment, we have space, any amount of space. Then we capture everything after that space. We capture everything. Yeah, we'll do that later. But I mean, that's the basic idea, I guess. To end line. Yeah. Yeah, that's it. So string literal. Gotcha, gotcha, gotcha. Look at that. And this is kind of why we should enumerate these things because, like, I don't. It's pretty low level right now. Like we're looking at these patterns. It's like I just want it to be more abstract, but it's not. What is this? Why are these both getting matched? Oh, duh. Another thing is wait a minute. Wait a minute. Wait a minute. Should that be wait, could that be possible? Could we literally just say this? Yeah, you can literally say that. This is literally valid in our programming language, guys. This is valid in our programming language. Look at that. This is fucking valid in our programming language. Look at that. See that? See that shit? Because right, because the idea of a character, single quote, with something in between it followed by a single quote. That's the whole idea. That's it. So this is valid. Yeah. Okay. Cool. Honestly, guys, I'm a little bit hungry, so I think I'm gonna go. But yeah, I guess I'm discovering more of how I'm getting more ideas, figuring out. We're just figuring shit out. So yeah, I mean, hopefully by the end of this, like this entire file will work. So here's the goal. We're getting this game, right? This entire fucking game made in JavaScript. I'm sick of writing JavaScript, so we're gonna convert it over to ZScript or whatever we call this thing. I don't know. It's our own programming language. Um, yeah, I mean, like that's the basic idea because because like look, this is just so much more pretty, in my opinion. There's a lot less redundant syntax, and especially the constants. All these constants are gonna go away. So like, look. I mean, like that's pretty nice, isn't it? Fuck const. It's just gonna be nice. So another thing is like string concatenation. Let's take a look at these strings, right? So like I mean we can just say this. Like look at that. This is so much nicer. We could just get fucking rid of the space if we wanted to. Like that. We don't need to do that. Either that or no, this is better. Like fuck f strings. You don't even need f strings if you have this. Like I don't know. You could have f strings if you wanted. I don't know. I don't know. I don't know. But yeah. Like this is gonna be really cool. It's just all gonna fucking work magically, and it's just gonna be nice. So yeah. Anyways, I'm gonna eat some